What I'm going to talk about now is probably something that you as young college students know nothing about, and that's mixing drinks. Here in Texas, we make gin and tonics from tonic water, gin, and Texas limes that just happen to be orange. And the recipe we use is 2 ounces of gin, 8 ounces of tonic, 1/8 of a lime, and a bunch of ice, but we won't worry about the ice. And if I pose the question, how many drinks can you make from 6 ounces of gin, 32 ounces of tonic, and 1 lime? I'm going to bet that you knew just like that you can make exactly 3 drinks. Now, how did you figure it out? Well, in your mind, you said, well, I've got 2 ounces of gin per recipe, and I have 6 ounces of gin, so I can make 3 drinks. And if I make the 3 drinks, I'm only going to use 24 ounces of tonic, so I have plenty of tonic, and I'm only going to use 3/8 of a lime, so I have plenty of lime. And that idea that you can figure out from the recipe, balanced reaction, and the amount of ingredients you've got, how much you can make, how much product you can make, that is the basis for the idea of the limiting reagent problem in chemistry. Now, just like milkshakes that I talked about in the previous tutorial, there is no difference between gin and tonic recipes and ingredients for making gin and tonics and using balanced reactions and amounts of reactants to figure out how much product you can make. These ideas are exactly the same. So if you struggle, come back to this idea and see if you can relate it to a chemical reaction. All right, so here's the problem we're going to address. For the reaction of phosphorus pentachloride and water to form phosphoric acid and hydrochloric acid, if you have 0.8 of a mole of phosphorus pentachloride and 2.9 moles of water, what is the limiting reagent? Okay, it's exactly the same as the gin and tonic problem, except we're going to express it now in algebra. And we'll see if we can translate the rules in the algebra back into the gin and tonic problem. So there are 2 methods, and whichever method that you're more comfortable with for determining which is the limiting reagent, there are 2 methods, and whichever one you're more comfortable with, that's the one you should use. And I'm going to introduce both methods. And method number 1 says, assume that one of the reactants is limiting. And if you think about what you did with the gin and tonic, you immediately recognized that you were going to run out of gin first, and then you did the calculation to see whether or not you were going to have enough tonic and enough lime. So this is very analogous to the method that you probably used in your head. The next step is calculate how much of the other reactant you would need, i.e., how much of the tonic were you going to need. And then if you have more than enough of B, for the reaction A plus B goes to C, if you have more than enough of B, then A is the limiting reagent. And if you don't have enough B, then B is the limiting reagent, right? So if it was gin and tonic, you assume that you ran out of gin first, calculated how much tonic you were going to need, and then since you had more than enough tonic, i.e., number 3, then you knew that gin was the limiting reagent. But if you were going to run out of tonic, then tonic would have become the limiting reagent. Okay? So these ideas are probably exactly what you did in your head to figure out how many gin and tonics you could make. So let's use these ideas to solve the problem. So we're going to assume, and again, you just have to guess one of them. Doesn't matter which one you guess. Assume that phosphorus pentachloride is limiting, and calculate how many moles of water are going to be required to react with all of the phosphorus pentachloride. So if we react all of the phosphorus pentachloride, we started with 0.8 of a mole of phosphorus pentachloride, and using the stoichiometry of the problem, we need 4 moles of water for every mole of phosphorus pentachloride, so we're going to need 3.2 moles of water to react with all of the phosphorus pentachloride. And now we ask, do we have enough water? And if you think back to the problem said we had 2.9 moles of water. And we need 3.2 to react with all the phosphorus pentachloride. So the answer, do we have enough water, is absolutely no. Okay? We only have 2.9, which means we're going to run out of water first before we use up all the phosphorus pentachloride. And that means that water is the limiting reagent. Okay, so that's method 1 for doing this problem. Let's look at now another method which gives exactly the same answer. So if you're more comfortable with method 2, use method 2. If you're more comfortable with method 1, use method 1. Method 2 is, here's our reaction again. Calculate the maximum amount of C that you can make from A and from B separately. Okay? In some sense, we're assuming that A is limiting by doing this calculation, and then separately we're assuming that B is limiting by doing this calculation, and then whichever, A or B, allows you to make less C, then that reagent is the limiting reagent. Okay? That is, figure out how many gin and tonics you can make, assuming that you're going to run out of gin first. Calculate how many gin and tonics you can make if you assume that you're going to run out of tonic first, and then whichever you can make fewer of, that's your limiting reagent. Okay? That's another way to do these problems, which is exactly equivalent. All right, so let's use this technique. Same problem with phosphorus pentachloride in water. What is the maximum amount of phosphoric acid? And you could either use phosphoric acid or you could use hydrochloric acid. Whichever one of the products you want to use, it's exactly equivalent. Just calculate how much product you could make. So the maximum amount of phosphoric acid that you could make from 0.8 of a mole of phosphorus pentachloride is 0.80 moles of phosphorus pentachloride times, go back to the balanced reaction, we can make 1 mole of phosphoric acid for every mole of phosphorus pentachloride, so we can make 0.8 of a mole of phosphoric acid from 0.8 of a mole of phosphorus pentachloride. Now, in a separate step, calculate the maximum amount of phosphoric acid we can make from 2.9 moles of water. And we go through exactly the same calculation. Now, it's 1 mole of phosphoric acid, 4 moles of water, because the balanced reaction says that you get 1 mole of phosphoric acid, but you have to use 4 moles of water. And we get that we can prepare 0.72 moles of phosphoric acid, assuming that we used up all the water. And then it's the one that we can make less product from. So we can make 0.8 of a mole of phosphoric acid, but only 0.72 moles of phosphoric acid from the water, assuming that the water is the limiting reagent. And so that means this is the limiting reagent. Water is the limiting reagent again, exactly the same conclusion that we came to before using method 1. Now I want to make one last final point about the two methods, and that is method 2 is easier to use in general if you have more than 2 reagents. So in other words, if this chemical reaction where A plus B plus C plus D goes to products, it's generally easier to use method 2 than it is to use method 1. But both of them are going to give exactly the same answer if you use them correctly. What have we done? In this tutorial, what we talked about is calculating basically what you're going to run out of first. And what you run out of first determines how much product you can make. And when we talk about theoretical yield, it's going to depend first on doing a calculation of what is the limiting reagent.